Okay, today we're going to cover two lessons. Not really cover them in terms of, it's not going to be totally brand new stuff, but this is lesson 8-6 and 8-7, and what we're going to be doing is solving trinomials, or quadratic equations by factoring, okay? So solving quadratic equations by factoring. So I think we already did one video on this. I can't remember. And basically we're going to go use that factoring skills we've learned and then set our factors equal to 0 and then solve. So we're going to use all the different techniques that we've come across. We were going to do one big huge lesson. We split it into two. Sorry, this video is coming a little late. As I was working, all of a sudden, my battery went out on my iPad as well as my Apple Pen. That's what happens with teachers. So let's go ahead and review what a quadratic equation is. And we talked about this before in another set of notes, I'm pretty sure. But again, vocabulary, vocabulary, vocabulary. So quadratic equation is a trinomial written in the form ax squared plus bx plus c equals 0. So this has to be a second degree. So your highest exponent can have an exponent of 2. That's it. That's it. Your highest term. If it's got a 3, it's not a quadratic equation. Okay. So again, reminding ourselves, the first guy is called the quadratic term, the guy with the square, and the a is called the quadratic coefficient. The bx is called the linear term, like line, because if you have something that's y equals bx, then you would get a line. And the b is called the linear coefficient. And the c, even if he has a variable attached, is still just called a constant. Okay, so what is the process of solving a quadratic equation? So to solve quadratic equations, we're going to get the polynomial in decreasing degree order. Oh, I'm writing decreasing and descending at the same time. I go to decreasing degree order. So that's highest exponent to lowest exponent, or no exponent actually. So just like what you see above. This is called standard form. So I'm referring to this guy right there. So standard form. So polynomial in descending degree order left of the equal sign and 0 on the right of the equal sign, okay? So then you're going to go ahead and you're going to factor the trinomial. Now, this trinomial can have a quadratic coefficient equal to 1. It could have a quadratic coefficient equal to greater than 1. There could be a GCMF, okay? What we're not going to have in this practice set is you are not going to be seeing let's see, difference of squares or trinomial squares. That'll come up in the second set of notes. Okay, so factor the trinomial. And so again, I don't know why, but we all forget this. Look for the GCMF first. Very important. Pull him out and then factor the trinomial. So we have two ways to factor the trinomial. And the first way is going to be the product sum game. And factoring by grouping. Okay, I used to call this the combo method. And then the other one could be, and some people, when you don't have a quadratic coefficient, this second strategy is easier to do. So if you only have a constant but not a quadratic coefficient, I think it's easy to list the factors of A and C, so the quadratic coefficient and the constant, and look for matches. Now by matches, I'm looking for a way to combine those factors, making bigger factors to see if when you add them or subtract them, depending on signs, you get the coefficient of the linear term. And look for matches. Okay? So we'll practice some of that. I won't, actually I'm just going to keep practicing the game, because if you want to do it a different way, that's awesome. But I'm just going to practice that, okay? And then you're going to use a zero product property. Oops, write that out. And basically that property says that in order for you to get an answer that equals 0, when you multiply, one of the numbers you're multiplying by has to equal 0. So what we do is we're going to set each factor equal to 0 and solve. And again, I noticed on your homework that a lot of you are doing all that math in your head. Don't do that. Show me the steps. I'll be looking for it when we take a test on this, which won't be next week, but would be the week after. And then because we have more than one set of answers, we're going to write the answer in solution set notation. Now the only time I don't write answers in a solution set notation is when it's a word problem. And then we have come across some problems, like when we're dealing with things, projectiles or trajectories, we ended up not writing, sometimes not both answers were good, right? So we eliminated an answer, so it just depends. Okay, so let's go ahead, and I'm just going to forewarn you, we are going to be doing word problems. So what's going to happen is I'm going to go off the screen, I'm going to pause it, write out the word problem, unpause it, and it looks like, you know, no time has passed. I recommend that you pause it, write down the word problem at your leisure, and then come back, okay? All right, so we have just a regular problem that we're going to go over. And the directions, well, we'll do regular problems and we'll do word problems at the end. How about that? So let's see, directions are just going to say solve. So this particular problem comes from 8-6, sorry, wrong, everything, 8-6. And, and then I'll do the ones from 8-7, mix them up together. So this one has a quadratic coefficient that's equal to 1. And then we'll do some from 8-7, and then we'll do the word problems all at once. So we have x squared plus 6x equals 27. So first off, this isn't in standard form. I don't have everything on one side, 0 on the other, so I start with that. That gives me x squared plus 6x minus 27 equals 0. Now I can play the game. I'm looking for factors of negative 27. That's your product number, 1 times negative 27. And a sum of positive 6. So that means my factors are going to subtract to give me 6. So off to the side. And a lot of people are able to see the factors already. I am going to get one factor that's positive and one factor that's negative. So let's see, it looks like negative 9 or positive 9 and negative 3. The reason why I put the positive 9 first is because my answer is positive, and that sure enough gives you the positive 6. So remember how I like to do it? I like to write my negative number in the left and my positive number in the right. So I'm going to go ahead and change from a trinomial to a 4-term polynomial by splitting the middle term. Okay, so that's going to become minus 3x plus 9x, and then I'm going to factor by grouping. So these two have an x in common, so I get x times the quantity x minus 3. Now again, a lot of people in their homework aren't showing me these steps, so I really don't know where your answer is coming from. So on the test, you're going to have to prove it out to me, so get in the habit of showing. So those two have a positive 9 in common. That's going to give me an x minus 3. Still an equation equals 0. So I get the miracle, x minus 3 gets factored out, leaving behind the second binomial that has x plus 9. Now I'm ready to do the 0 product property, so I'm going to have x minus 3 equals 0 and x plus 9 equals 0. So inverse operations to get the x alone. I add 3 to both sides on the first one, and I subtract 9 from both sides to get the second one. And I get x equals 3, and I get x equals negative 9. Now you can always test this out. Plug those numbers back into the original equation and see if the left side equals the right side. So for example, 3 squared is 9, 6 times 3 is 6 times 3 is 18, 9 plus 18 is 27, so 3 works. Negative 9 squared is 81, 6 times negative 9 is negative 54, 81 take away 54 is 27, so these both work. So solution set notation, it's the braces, looks like a forehead, a nose, and a chin, and there's your solution. All right, next one. Let's see, hold on one second. Okay, second problem, we're going to do, let's see, page 513. All right, and we're going to do 3x squared, and then equals 10x, and then minus 8. So again, we got to get everything on the left side, constant or 0 on the right. So we're going to subtract 10x, inverse operations, add 8, and our quadratic equation is 3x squared minus 10x plus 8 equals 0. So I'm going to go ahead and play the game. I'm looking for factors. This time the product is going to be a positive 24, and the sum number is going to be a negative 10. And then I'm going to think of factors of 24, positive 24, that add up to give me negative 10. So to get a positive 24, my signs have to be the same, and then in order to get a negative sum, they both have to be negative. So again, you might go through the process to figure out those two numbers, or you might just see straight away that if I have -4 and -6, that will give me -10. So this is my pattern, and again, it doesn't matter which one goes first because they're both negative. So now I'm going to rewrite that trinomial into a 4-term polynomial, and we're going to get minus 4x minus 6x. Okay, and then we're going to go ahead and factor by grouping. So these two have an x in common, so that gives me x times the quantity, 3x minus 4. And then I am going to have to pull out a negative on the second grouping, and they're both even, so I can pull out a -2. So -6x divided by -2 is a positive 3x, and 8 divided by -2 is a -4, n equals 0. So we have 3x minus 4, and then we get x minus 2. And that equals 0. So we have 3x minus 4 equals 0, and x minus 2 equals 0, and then we do inverse operations to solve. So we're adding 4 to both sides on the left one, adding 2 to both sides on the right one. That gives me 3x equals 4, and x equals 2. And then I have to go one more step and divide both sides by 3. So yes, it is okay to have non-integer values as long as they're real numbers. So I get 4/3 and I get x equals 2. So the solution set contains both 4/3 and 2. Okay. All right, I'm going to go switch to the next page, and I'm going to put in my word problem. So see you in just a sec. Okay, so here's your word problem. You might want to pause right now and copy it and then come back. Ling is designing a poster. The top of the poster is 4 inches long, and the rest of the poster is 2 inches longer than the width. If the poster requires 616 square inches of poster board, find the width of the poster. Okay, so this is where things get ugly sometimes, is that we get some obnoxiously large numbers. So first things first, draw a picture of what the situation is. So I'm going to draw a poster board. It's a rectangle. It says the top of the poster is 4 inches long. So that is 4 inches. And then it says that the rest of the poster is 2 inches longer than the width. Okay. Oh, I labeled that wrong. Sorry. I need to read that better. When they were talking about top, they weren't talking about dimensions. So let me do that again. So designing top of the poster is 4 inches long. So what they're talking about, is this is the top of the poster. And that's 4 inches, okay? And then it says the rest of the poster is 2 inches longer than the width. So let's put in a variable here. This is your width. From this corner to this corner is your width. So I'm going to define W equals width. And then that means that this would be the length. So we're going to have L equals length. And then going back to what it says about the length, it says the rest of the poster is 2 inches longer than the width. So if the width is W, from here to here would be W and then plus 2. Okay. So then it says if the poster requires 616 square inches, so when I read that label, what that tells me is I'm dealing with area. Oops, that's supposed to be the other pen. So I'm going to be dealing with the formula, and I'm going to put it over here to the right, area equals length times width. Well, they tell me what the area is. They say it is 616 square inches. Okay, so we get length times width equals area. So I'm going to do the length is the W plus 6. So if I take these two and add them up, they would be the length. The width is just the W. So I'm going to get W and then times the quantity, W plus 6. 2 plus 4 is 6. And that's going to be equal to the total area, which they told me in the problem, is 616. Okay, so I'm going to go ahead and solve this, distribute. I get W times W is W squared. W times 6 is plus 6W equals 616. I'm going to subtract 616 from both sides, and I get W squared plus 6W minus 616 equals 0. So here comes the fun bit. I need to come up with two factors of 616 that's going to give me a difference, because it's a negative 616 of 6. So I'm going to tell you, I don't know my factors of 616, and I might be here a long time trying to figure out what the two factors are. So I'm going to show you an alternative way when you have super large numbers. How can you come up with the two factors to put into the product sum game? So right now, in our product sum game, we're going to put the sum is negative 616, and the sum number is positive 6. So what we're going to use is factoring. We're going to do a factor ladder. So I have factors 4, because I know 16 is divisible by 4. 4 goes into 6 once with 2 left over. 4 goes into 21 5 times with 1 left over. And 4 goes into 16 4 times. Now I know those can't be the factors because they would subtract to give me 150, okay? So I'm going to keep breaking down numbers. So I know 254 is even, so I'm going to divide out of 2. So I get 15 divisible by 2 is 7 is 14 with 1 left over, and 2 goes into 14 7 times. Okay, remember what my goal is. My goal is to get to 6, okay? So let's see. I've got, 4 times 2 is 8. 77 take away 8 is going to give me 69. That's not going to work. And if I multiply 4 times 77, it'd be really big. So I'm going to keep breaking down. So I've got 7 times 11. Okay, so let's see. Some different things that I can try. 4 times 11 is 44. 2 times 7 is 14. So 44 take away 14 is going to give me 30. That's not it. How about 4 times 7 is 28. 2 times 11 is 22. Ooh, I think that's the match here. I think we've got it. So that's 28. That's 22. And they do subtract to give me 6. So because I have a product that's positive, the bigger factor is going to be the positive one. So I'm going to put them over here because a negative one I want to write first. Okay, so that's what I do when I have these super big numbers. So then I get W squared is going to stay, and negative 616 is going to stay, and equals 0 is going to stay. And then I'm going to get negative 22W plus 28W. And then I'm going to go ahead and factor by grouping. So the first two have a W in common, so that gives me W times the quantity, W minus 22. And then the second, let's see. I know 16 has a 7 and a 2 is a 14. I know 14 can go into both of those. And and then another 2. I think actually 28 can go all the way into that guy. Yeah, he does. So I'm going to add 28, and that's going to get me W minus. So if I take, and I can use my factor ladder to help me with this now. So I took the 7 times 2 is 14, and then take away a 2, and that leaves me a 2. So I have a 7. Oh, that's stupid what I'm doing. Let's try that again. Hello. Okay, so 28 and 6/16. So if I take away 28 from 6/16, oh, that's going to give me, brain. I pull out a 22, a 28, I am left with 22, so I get W minus 22. We're going to set each one of those equal to 0 and solve. So I add 22 to both sides here, subtract 28 from both sides here, and I get W equals 22 and W equals negative 28. Well, I'm hoping that you can see straight away that one of those answers is not realistic, and that would be I can't have a dimension that's negative. So my answer is going to be this. So I'm going to write my final answer up at the top. So the width is 22, and then it would just be regular inches. Okay? All right, so here's your next, oops, go back to black. Next problem.